A bike shop mechanic with 12 years on the wrench will tell you something the marketing department never will. Behind the counter, after the customer has left with their new tubeless wheel set, mechanics shake their heads. Not because tubeless is bad, but because it is more complicated than the industry has ever admitted out loud. Tubeless tires were sold to cyclists as the future, the end of pinch flats, the smoother ride, the lower rolling resistance. In many ways, that promise is real. Yet the people who set them up, repair them, and clean up the aftermath when they fail, have a more complicated opinion. Is tubeless the most important tire innovation in modern cycling? Or is it a maintenance burden the industry has dressed up in marketing copy? The answer is more interesting than either side wants to admit. To understand the story, you have to start in 1999. That year, the French wheel manufacturer Mavic launched something called the UST standard. UST stood for Universal System Tubeless, and it was the first bicycle tire system designed from the ground up to run without an inner tube. The technology had existed in the automotive world for decades, but applying it to a thin, flexible bicycle tire was a different kind of engineering challenge. Mavic's UST system included airtight rims, specifically shaped tire beads, and a precise interface between the two that locked under pressure. It worked, but it was expensive, heavy, and only available to mountain bikers. The real breakthrough came a few years later, from a small American company in Colorado called Stan's No Tubes. Stan's invented the conversion kit, which let riders take a regular tire and a regular rim and convert them into a tubeless system using a rim strip, a valve, and a bottle of liquid sealant. The sealant was the secret. As the wheel rotated, the liquid coated the inside of the tire, sealing small holes the moment they appeared. Suddenly, tubeless was not just a feature for premium wheel sets. It was something every rider could install in their garage on a Saturday afternoon. The mountain bike world adopted it almost immediately. The road bike world took another decade, mostly because road tires run at much higher pressures and required tighter manufacturing tolerances to seal reliably. But the marketing promise in both cases was the same: fewer flats, lower rolling resistance, smoother ride, better grip at lower pressures. And on paper, all of that is true. The problem is what the marketing copy did not say. This is where sealant becomes the centerpiece of the entire story, because tubeless does not actually prevent flats. It seals small punctures in real time while you are still riding. It is reactive, not preventive. The sealant is a latex-based liquid, sometimes mixed with small particulate matter, that lives inside your tire and rushes to fill any hole that opens up. Brands like Stan's No Tubes, Orange Seal, Muck Off, No Puncture Hassle, and Silka Ultimate dominate the market. Each formulation has different particle sizes, different drying times, and different effective temperature ranges. And here is where most riders never get told the full truth. Sealant dries out. Every 2 to 4 months, depending on climate, the liquid inside your tire turns into a useless rubbery wad and has to be removed and replaced. If you forget, you wake up one Saturday morning to a flat tire that the sealant cannot fix because there is no sealant left to do the work. So already, the math gets more complicated than the marketing. A tube tire requires no maintenance. You install it once, you ride it. A tubeless tire requires sealant top-ups, a check on the bead seal, and occasionally a complete tire removal to clean out dried sealant from the casing. The labor adds up. And then there is the setup. This is where the mechanic's perspective becomes the whole story. Setting up a tubeless tire correctly requires the right rim, the right tire, the right tape, the right valve, the right sealant, and the right inflation source. Some tire and rim combinations refuse to seat together no matter what you do. The bead has to pop into a specific groove on the rim, and getting it there often requires a sudden, high-volume blast of air, far more than a normal floor pump can deliver. Bike shops solve this with a tubeless inflator, a pressurized tank that releases all its air at once. Without one, riders end up using compressors, soapy water, and increasingly desperate techniques that result in sealant explosions across their garage walls. Mechanics see this every week. The customer who tried to do it themselves gave up and brought in a wheel covered in dried sealant and a tire that won't seat. Some shops charge a premium for tubeless installs precisely because they take 3 times longer than installing a tube. But the real question is what happens out on the road or trail, because this is where tubeless either delivers on its promise or fails spectacularly. When tubeless works, it is glorious. A small thorn punctures the tire, the sealant rushes to the hole, the tire stays inflated, and the rider never even notices. There are real-world stories of riders finishing 100-mile gravel races with 3 or 4 punctures sealed mid-ride that they never knew about. Mountain bikers running aggressive low pressures get traction and compliance that tube tires cannot match without pinch flats. Racing on tubeless can feel like cheating compared to the tubes most cyclists grew up with. That part of the marketing promise is genuinely real. However, when tubeless fails, it fails ugly. A puncture too large for the sealant to handle becomes a fountain. White or pink liquid sprays across the rider, the bike, the next wheel behind them in the pace line. Then the rider has to choose. Plug it with a Dynaplug or a samurai sword tool, hope that works, and ride on. Or admit defeat, install a tube as a backup, and limp home. Many tubeless setups end the same way, with a tube installed as a roadside repair anyway. So the tubeless rider has been carrying a tube and a pump and a multi-tool the whole time, plus the additional Dynaplug kit, and the spare valve cores and the backup sealant. The toolbox got bigger, not smaller. The performance data tells the most honest version of this story. The independent testing site, Bicycle Rolling Resistance, has run hundreds of tests on the same tires set up tubed and tubeless. The result is that on rough surfaces, tubeless tires often have measurably lower rolling resistance, sometimes by 10 or 15 watts at race pace. On perfectly smooth surfaces, the difference closes to almost nothing, and in some cases, tube tires actually win. The advantage is real, but specific to the conditions. A road racer on perfect pavement might gain very little from tubeless. A gravel racer on chunky terrain might gain a meaningful edge. So what do mechanics actually think about this? The honest answer, after talking to enough of them, is that tubeless splits the cycling community along surprisingly clean lines. Mechanics overwhelming recommend tubeless for mountain bikers, gravel riders, and anyone running tires wider than 35 millimeters. The lower pressures, the rougher terrain, the higher likelihood of small punctures, all of these tilt the math heavily in favor of tubeless. The performance gain is real, the reliability is real, and the trail-side flat fix is genuinely better than wrestling a new tube onto a muddy mountain bike trail. Mechanics are quiet about whether tubeless is right for the average road cyclist. Some recommend it for racers and long-distance riders. Others say outright that for a recreational road rider doing 50 miles a week on relatively clean tarmac, the headache of setup, sealant maintenance, and occasional roadside disasters is not worth the marginal performance gain. There is a quiet movement of road cyclists, and even some pro mechanics, who have gone back to high-quality tube tires with latex tubes for race day. The performance is nearly identical. The maintenance is far simpler, and the failure mode, when it happens, is something every cyclist has been able to fix since they were 8 years old. So is tubeless a scam or genius? It depends on who is asking and what they are riding. For mountain bikes, gravel bikes, and adventure setups, tubeless is genius. The technology earns its complexity. For race day road bikes ridden by serious competitors, Tubeless can be worth the trade-off, especially with the latest improvements in sealant and tire design. For casual road cyclists doing weekend miles on a clean local route, Tubeless is often more trouble than the marketing suggests. The honest mechanic behind the counter at your local bike shop will probably tell you exactly that, if you give them the chance. The cycling industry built Tubeless into the new normal because it was a real innovation that also happened to sell new wheels, new tires, and consumable sealant on a regular cycle. Some of that is good engineering. Some of it is good business. The two are not mutually exclusive, and pretending they are is its own kind of myth. Tubeless works, just not for everyone, in every situation, the way catalog cover would have you believe. Thanks for watching. If you want more honest takes on what the cycling industry isn't always saying out loud, stick around.